Here, and a squared plus b squared equals c squared was the formula. Pretty simple formula. A and b are the two legs. C is the hypotenuse, and we had to figure out most of the problems yesterday. We were given two sides, and we had to find out what the third side was. Sometimes it was the hypotenuse, sometimes it was the leg. We had to figure out what that third missing piece was, and you could put that into the a squared plus b squared equals c squared, and figure out that pretty quickly. Today we're going to do the converse, okay? If, and notice on these, this is a triangle. We want to determine if it's a right triangle. There is not a 90-degree angle in there to start with, okay? Obviously, if there was a 90-degree angle, then we would know immediately it's a right triangle, right? So we're trying to determine if this is a right triangle. If it is a right triangle, that means it satisfies the Pythagorean theorem, okay? And so on most of these, you can kind of tell where the right angle should be, if it really is a right angle. This is my A, this is my B, and this is my C. If you're not really sure which one's the longest and which one's the shortest, then you could take the square root of 113 and figure out what the decimal is, and it probably is bigger than 8 and 7, okay? Because 8 squared is 64, 7 squared is 49. So if I take the square root of 113, it's going to be a number bigger than 7 or 8, okay? Because 8 squared is 64, and so it's quite a bit bigger than that. So here's what we're going to do. We're going to go 8 squared plus 7 squared equals the square root of 113 squared. And it kind of looks like this is difficult to do. And really, to be honest with you, you probably don't even need a calculator here, okay? Unless you don't know what 8 squared and 7 squared are. Maybe you need it for that. But 8 squared, those are the numbers that we should start to be able to recognize more and more. So 8 squared would become 64. 7 squared would be 49. And we kind of talked about this briefly yesterday, but when I square a square root, what happens to the square root of 113? Yep, except for it gets rid of the radical. So the square root of 113 squared is just 113. Gets rid of my square root. Does 64 plus 49 equal 113? Yeah, okay. And so we would say yes. If that satisfies the Pythagorean theorem, then that means it's a right triangle, and that means that this would be a 90-degree angle right here. If that equation does not work, then it's not a right triangle. Okay, now this one's a little bit harder. It's not necessarily harder to identify which piece is which. 36 and 15 are my A and B, and remember those are interchangeable. It doesn't matter which one's which. So we're going to go 36 squared plus 15 squared equals 4 radical 95 squared. Okay, now this is a little bit trickier, okay, and you can use your calculator on this, but to understand what's going on here, first of all, what is 36 squared? 1,296. Okay, 15 squared, 225. Those are pretty straightforward, okay? Now there's a couple of different ways that you could do this, kind of depending on your calculator, might depend on how you do this. 4 times the square root of 95 is going to give you a decimal, okay? And I'm okay with going ahead and getting that decimal. And then we're going to square that decimal. So hit 4 times the square root of 95 and then square it. What's really happening here is when I take 4 radical 95 squared, I've got to take 4 times 4. And when I take radical 95 times radical 95, that would just give me 95. So really it would be the same thing as 16 times 95. So there's a couple of different ways that we can get there. Probably the easiest way is to just put this into my calculator and then square it. What do I get? 1,520. Okay, if I add the left-hand side up, I get 1521. Does 1521 equal 1520? Obviously not. Those are not equal. So here we would say, no, this is not a right triangle. It's close, right? Really, really close. They're only one off, but they have to be equal. And so that's all we're doing on ones like that. Okay, so try the bottom two. See if you can set up the bottom two and determine if those two are yes or no. I'll do them as you guys do them, and we'll see what we get. Okay, the one on the left. Anybody get that one? Anybody want to take a shot at that one? Hendricks, did you get it? No? Arthur, did you get it? You what? Not a right triangle? What'd you get for the two values on the left and the right?
484 and 196.
Okay, and if you added those two together, what'd you get? 680. And then what would 26 squared be?
676.
676. So I get 680 and 676. Those two are obviously not congruent, so that would be a no. Okay. On the one on the right, one thing I will point out here is make sure you put this whole thing in parentheses, the 3 radical 34, because I want to take that whole thing and square it. I don't want to square them individually. I don't want to square the 3 and then square the radical 34. I want to square the product of those two. So the multiplication has to happen first, and then we square it. So over here, we get 81 plus 225. Those two are pretty straightforward. Get 306. Over here, this is the part that's a little bit tricky because of the 3 radical 34, but the two sides do get equal to one another, and so we would say yes, this is a right triangle. Okay. And what I would tell you is be careful, because sometimes this looks like it might be a right triangle, so don't just look at it and say, yeah, it looks like it is, right? We don't know that for sure. Same thing up here. It's really, really close to a right triangle, so it might look like it's a right angle because it's really close to a right triangle, but it's not quite there, okay? So don't go off of looks on those. You have to go off of the information that we know, okay? Anybody need help with their calculator or anything like that? Everybody figure out how to type those in their calculator? All right, this part here is going to be a little bit tricky, and there's a little trick to it I'm going to teach you that makes this a little bit easier to determine, okay? When we do this, typically with the Pythagorean theorem, we go a squared plus b squared equals c squared. But when I do problems like this, where I'm trying to determine what type of triangle it is, then we always put c squared on the left. So I'm going to put c squared over here, and then I'm going to put a squared plus b squared on the right. Because it doesn't matter what side it's on. Typically, usually the equation is written a squared plus b squared equals c squared. But here's why it's really important, and if you do it this way, it'll make it so much easier for you. If c squared is greater than a squared plus b squared, when I think of greater than, I think of bigger, right? And a really big angle is an obtuse angle. So greater than means obtuse. If my symbol is less than means smaller, smaller than 90, okay? and as far as an angle goes, would be acute. So if c squared is less than a squared plus b squared, it's acute. If it's greater than a squared plus b squared, it's obtuse. Or if it's equal to, then it would be a right triangle. So you're going to have questions, and it's going to ask you, is this an acute, a right, or an obtuse triangle? So on the questions like that, always put c squared on the left. Otherwise, it'll be backwards, and your mind will get a little bit, it's flip-flopped, okay? And it's then kind of, I think, harder to think about. So we're always going to put, we don't have a picture on these, but what we talked about yesterday is the c value is always the big value, okay? So the c value is going to go on the left. The A and the B, remember those are interchangeable, but I'm just going to list them in order, A, B, and C. And I'm going to just punch this into my calculator. I don't expect you to do 6.1 squared in your head, right? So 6.1 squared, what do we get? Okay, good. And then over here, you should be able to just type this all in at once in your calculator. 4.3 squared plus 5.2 squared. You shouldn't have to separate those. You should be able to do it all at once. Okay, what do we get there? 45.53. Okay. And then all we have to do is compare them. 37.21 is smaller or less than 45.53. If you remember, if you have a hard time remembering which one's less than, which one's greater than, less than always points to the left, greater than, right, R, right? Left is less, R is right. And so if this points to the left, that means it's less than, so that means it's acute. Okay, this one over here. 6 squared is going to go on the left, and then 3 squared plus 4 squared. I'm going to always leave that space in the middle open, because here we don't know if it's less than, greater than, or equal to until we get to the end. So I always leave a little space right there. And then when we get to the end, we'll fill in the information. So 6 squared, this one's a little bit easier, is 36. 3 squared plus 4 squared is 9 plus 16, which is 25. 36 is bigger than 25, so we're going to put greater than, and greater than means obtuse. Okay? Here's why it's so important to put c squared on the left. If you wrote 25 here and 36 here, now the symbol is less than, and that's confusing, right? Those two are the same statement, but so much easier when I see greater than means obtuse. So that's why it's so important to always put c on the left. It makes a whole lot more sense in our equation, I think. Okay, otherwise it'll be backwards and harder to think about. Okay, on this one here, this is your A, B, and C. So we're going to go 3.5 squared, and then 2.1 squared plus 2.8 squared. Okay, 3.5 squared, what's that give us? Okay, 12.25. Okay, and then 2.1 squared plus 2.8 squared. You should be able to do that all at once. You don't have to separate them. That should also give me 12.25. So those two are equal, and if they're equal, then it would be a right triangle. So we're going to simply say acute, obtuse, or right. That's it. Those are the three answers there. Okay, I don't think there's any reason to do the last one here. One thing I do want to mention, because we did not do one like this yesterday. You had a couple of problems yesterday on big ideas. And I don't remember what the numbers were. I'm just making these numbers up. But it's asking me for the area of the entire triangle. Okay? This whole big triangle right here. So we have to remember what the formula for area of a triangle is. How do I find the area of a triangle? Okay, base times height, and what else do we have to do? Not close, not square root. Base times height divided by 2. Okay, base times height divided by 2. Or you might remember it as 1/2 base times height. Either one of those, same thing. I think base times height divided by 2 is a little bit easier. Now, here's how we're going to get there. The entire length down here is 16. Because these two lengths are the same, and I'm just, like I said, I'm making these numbers up. I don't know if this is the exact problem from homework, but you had one very similar to this. Then I have to find the height. So we're going to use the Pythagorean theorem to find the height. What would this piece right here be? The piece from the middle to the edge. What do you think that altitude does to the base? It's going to split it in half. Okay, it is the bisector to it. That goes back to earlier in the year when we say as long as these two are the same, then that means this is the perpendicular bisector of the base. Okay, so we know those two are the same. So we know these are both 8 and 8. 16 divided by 2. So we know this is 8. So we can go h squared plus 8 squared equals 12 squared. Okay, and then I can solve for h. And my area would be 16 times whatever h is divided by 2. We got to use 16 for the base because that's the base of the whole triangle. Okay, but we needed 8 to find the height. Okay, so there's that one. I think you maybe had a couple of those. And then the other one was a kite. And I had some diagonals in here. Just remember that these two pieces are the same and these two pieces are the same. So if I find what the length of this one is here, then this one would be the same. If I find what the length of this one is here, I know this one's going to be the same. Okay? And they give you some different lengths here, and I don't remember what those are. But if I say this is 12, this is 10, and this is 12, then if I find this triangle would be the same. Okay? And if this is 12, and let's say that this piece down here is 20. And once again, I don't remember what the numbers were off the top of my head, but I would go 12 squared plus 20 squared equals c squared, and whatever I get here would be the same as what we do here. The question is asking what the perimeter of the kite is, so then once I find all four sides, I got to add up all four sides to get there. Okay, so a couple of different questions, still using the Pythagorean theorem, but kind of like application type questions that I did not go through with you yesterday. If you need help with those, let me know and I can help you out with that, but just trying to help you out, giving you a little bit of an idea on that. Okay. Anything else from big ideas yesterday you guys have questions on? Okay. Wasn't any like that on the notes.